So, hello everybody. I will be joining a group of people who are already uh, have been complaining about the state of the slum and mapping in the robotics community. With a presentation, I'll be focusing on the problem of the good, the bad, and the ugly maps. So, reference-free map quality assessment. So, to start with, why I'm even here. So I'm Tomasz Kucner, and I'm currently transitioning from Aalto University to Aalto University. And basically, I have two credentials that supports my presence here. First is that I work on the reference-free map quality assessment, and the second thing is that I'm currently involved in the work of three-dimensional map data representation working group standard. So I also have an insight on the problem on how to standardize the map representation. So before we will go into the problem of how, about the core of the presentation, let's first ask ourselves a question: how robots think about the world. So robots are reasoning. So how does it work is that they observe external world. There is some kind of perception model that provides the information for the reasoning module. With use the information or knowledge in more general, and then spits out some kind of actions that are affecting the external world. And this is something that it can take different shapes, different architectures has been developed in order to implement this, but this is something fairly standard. However, what can we do if we sort of think about this internal part of the internal part of this loop in the same way as we are thinking about the external world? So here we are getting into the place where actually we can develop tools, which here for brevity are called assessment, which are reasoning about the way how the robot is reasoning and about the knowledge that the robot has, and then is spitting out some kind of ways to modify the ways how the robot is reasoning and what that the robot knows. So this is exactly a copy of this loop, which is governing the robot behavior with respect to the external world, and the robot behaves exactly the same with respect to its internal world. That's why the robotic introspection. So which parts of this loop I will be focusing today? I will be focusing especially on the knowledge part and the assessment part. There is, as you can see, there is still a huge part that I'm leaving away. So I'm not talking about the internal reasoning. I'm not talking about the internal knowledge or the way how what kind of actions can be developed. I'm only focusing on the knowledge, so the maps, and the assessment, how to measure their quality. So we are throwing around quite a bit the word map, and we are doing it quite a lot today. But before we will jump into the discussion, I would like to have a step back and actually explain to myself and to everybody, even though that you probably know this word very, very well, what the map really mean. And I'm here quoting the already mentioned by Francesco map standard. And there is a definition of map where it's called that a map represents the robot's knowledge about its workspace and surrounding environment, as well as objects contained therein. So the first keyword that appears is knowledge. And what does it mean that it's knowledge? So knowledge, it doesn't really only focuses on the shape of the environment or the presence of the world. Knowledge is something wider. And the second focus in this statement is also that it is spanning outside of the term of its workspace. It is really describing also the robot's environment as well as the object. What does combination of knowledge and workspace, environment, and object implies? That implies that the map, that is the knowledge, cannot only be focusing on the shape of the environment. And this is probably the first problem that I want to mention during my talk today, is that all the maps or all the mapping or the let's say not all, because that's a bit unfair, but all the commonly used mapping approaches are focusing on building the map of the shape of the environment, simultaneously leaving behind the problem of the semantic labels, affordances, or physical characteristics of the environment. There is still very little work about maps which are reaching outside of this shape and this maybe semantic labeling of the environment. Okay, so we talked about how the robot is reasoning. We talked about what is a map. And now let's talk a bit what is a good map. And once again, term that any one of you present here in this meeting have some intuition about what a good map is. Maybe you even can make some definition or have some working definition for the purposes of your work. However, there is no clear, commonly accepted definition of what a good map is. Probably the one of the definitions that I think is most acceptable, at least in my opinion, is definition provided by Leonard and Durant White in their publication from 1992, where they state that we feel the ultimate test of map is not does it look good, but how accurately, adequately, or quickly can X be performed with it. Even though that they are sort of only focusing on the second part of the statement, in practice they are providing two definitions of a good map. First is it's how it's look, so we will call it an appearance criterion, and the second is how well actions can be executed with the map, and we will call it utility criterion. So those two criteria provide significantly different approaches towards the problem of map quality assessment. So the appearance criterion focuses on the measuring global and local parameters of the map. What does it mean? In contrast, the utility criterion doesn't really care that much how the map looks, but more is focusing on measuring how the robot performs with the given map. So what does those features that the appearance criterion focuses can be? So there are quite a few of them, and today they have also been mentioned. So some of them can be called like, are the walls curved or are they straight? So are the surface points over the wall have low or big covariance? Are the planes well aligned? Are the walls related in this or other way? In contrast, the utility criterion doesn't care about features of the map. It cares only on the performance. So we can clearly see here that this difference, that the utility criterion will look at the quality of localization, quality of motion planning, and quality of task execution. We see that there is no mentioning about the map itself or the features of the map. So what are the pros and cons of each method, of each of those criterions? So the appearance criterion, the first pros is that the method is direct. What does it mean is direct? So that means that we are actually measuring something that we have at hand. We don't need some kind of proxy to say if the map is good or bad. If we have a tool to measure the map quality, we can use it directly with the using appearance criterion. It's also fast, and maybe it will be misleading a bit, because one can say that, okay, but doing all the classification of the local features can take time. Yes, but in contrast of running multiple experiments that will happen in case of the utility criterion, it's substantially faster. The third pro of the third benefit of appearance criterion is that this type of criterion is isolated from other components. What does it mean? It means that we can just pluck out the map and just focus on the map. Our measurement is not distorted by how the other modules are performing. Maybe our localization modules is bad, maybe some parameters in motion planner are not tuned correctly. This will not affect how well, this will not affect the score that the map will receive, in contrast to the utility criterion. And finally, there are easy to design metrics, and this is a bit of a pitfall here, because even though that it's easy to design metrics, we can see like, okay, I can measure the curvature of the walls, I can measure the covariance of the points on the walls, and so on and so forth. It's very easy to design them, but the question is like how to use them properly. So this is still a bit problematic. Apart of those benefits, there are also two substantial issues with this criterion. First, so there is no direct connection, and I would say yet, with the robot's performance. There is no clear way of saying what kind of parameters, of what kind of features will assure a correct localization or the best possible motion planning. We have, as practitioners, some intuitions that probably some low covariances on the points and straight walls will be better than bendy walls and high covariances. But as I say, this is intuition. Finally, which is not finally, but what is connected with this problem is that the results of map quality assessment using the appearance criterion are fairly difficult to interpret, because even if we know that the walls are a bit bended and that the covariances of the points on the walls are a bit high, so that means that we have a bit of noise, and that the planes alignment are maybe not very good, what does it really mean for the performance of the robot? Is it still acceptable? Maybe not. Maybe a too straight wall or too low covariance will actually make it even worse to perform, which in some cases can happen. So this is bringing a bit of an issue. Similarly, utility criterion also is not free from such problems. So, and benefits as well. So let's start with the benefits of the utility criterion. So the key benefit is that there is direct relation to robot's performance. So if we take the map and we run experiments over and over again, we will know that this map is, and we measure the performance of the robot, we know how well the robot will behave in this environment. Second, the results are easy to interpret. We don't have to think if the covariance is high enough or low enough to assure the good localization. We just see that the localization is good. However, there is also a list of issues with the utility criterions. So first of all, it's time consuming. The experiments need to be run over a long period of time. It's usually not enough to run 1 or 2 experiments. The second issue is that this criterion is affected by non-map related factors. It means that our localization module, motion planning module, the robot itself can affect the scoring process. Finally, it might be dangerous. Like any one of us has seen or maybe even experienced a robot falling down the stairs because there was localization error. And if we don't know if the map is good, most likely localization error will appear, and that's what can happen. Finally, it's indirect. We know how well the robot performed one task, but we don't have general score for the map which will tell us if the map is good or bad. Finally, the metrics that we have to design are usually very complex. So we have to think about the methods to measure the performance of the robot, both in the terms of like how to measure the behavior of motion planner, as well as how to come up with some good tools to measure this performance. So having those two criteria in mind, let's ask ourselves, what kind of tools are already out there available that can be used to actually assess the map quality? So there are two major classes of tools for assessing the map quality. One is the reference-dependent tools, and the second one is reference-free or reference-independent tools. So reference-dependent tools require some kind of ground truth information, some kind of information about the perfect environment. The reference-free tools has to work without the information with the access to the perfect information about the world. And where they are finding their use. So let's start with the reference-dependent assessment tools. So they are mostly rooted in the Slum community in benchmarking, and here I would like to emphasize two of them. So first is work published by Kummerle et al. In 2009, and I think that the robotic in the Slum community is still using some kind of variation of this method to this day. And this method is basically saying that we know where the robot was when when the map was built, and now we are checking what the Slum algorithm estimated where the robot was, and then we are comparing the error between those two estimates. It's very good. It's very efficient. It provides us with very good measurements. This is on where the whole Slum community is standing. However, there is one key problem. We need to have access to the ground truth where the robot was during the map building. That means that we already have in the environment a perfect localization system. Why wouldn't we use this perfect localization system and instead use this other method to have some imperfect localization? The second method also relies on the ground truth representation, and here we have map comparison. And in this case, instead of relying on how well the robot was localized, it is checking how well the robot is representing the environment. And here I'm showing a figure from paper by Schweigger and Birk, where they show how to build a topological graph to compare those two maps. Okay, we have the reference-based representation. Let's briefly talk about reference-free representations. So let's start with something that, once again, most likely each one of us did at least once in their life. So visual inspection. After the mapping procedure, each one of us just took a map and says like, okay, this map looks good, this map looks bad, we need to remap. This is very common, and this is visual free. This is reference free. It requires our expertise and our experience, but we don't have access to any kind of ground truth information. The second is the performance assessment. So we are going into the environment, we are taking the map, and we are running tests over and over again. And based on how the tests are executed, we are deciding if the resulting map is if the resulting map is good or bad. And one can say that those methods that I mentioned so far is like sort of like, yeah, but it's not really the proper scientific method, not really proper industrial method. The answer is yes, you're right. But this is the reality. This is how we are doing this because we don't really have much better tools to do this. Although some tools are being developed. So as Naoki Akai mentioned in his presentation, one of the approaches to measure if the maps are correct or not is just to check alignment of consecutive scans. So we are just checking if the scans are well aligned in the resulting map. The second approach is to build some kind of structure assessment. And in this case, this is my work with Martin, where we have looked if we can extract the structure of the environment and see if this can be directly projected into a matrix for the map quality. It looks that it's promising. There are some benefits from that approach. And finally, and this is something that I will leave as introduction for the next talk. So then finally, there is Slum certification, where actually the Slum process is being certified without access to the ground truth. And I will be not diving into it because after me, Luca Carlone will be presenting this problem. So I will move on from that. So where we are so far? So we have discussed what are maps, what are good maps, and how we measure their quality. And what now? So the answer is that really any of the questions so far is not fully answered. We don't have a good definition of what a good map is. We have the definition by Leonard and Durant-White. We have the definition from the Slum community, where the quality of the map is defined as the quality of the localization during Slum procedure, or the similarity between the ground truth map and the resulting map, which is a definition of map quality, but is useless in the context when we want to measure the map quality in the wild, outside of the test bed or outside of a benchmark domain. The second thing is the methodology gap. So we don't have really tools allowing us to assess the quality of the knowledge that is presenting in the map beside of the shape. All those semantic labels, affordances, physical characteristics, so in general semantics, are still waiting for reliable ways of evaluating their quality. Finally, and this slide is empty and will remain empty, we don't have any common tools to perform reference-free map quality assessment. We have great tools, or decent tools at least, for running Slum, for running localization, for running motion planning, but there is no tool that is which is accepted by the wider community, where people will say like, okay, this is the tool that can be used for assessing the quality of the map. So what are the take-home messages from my talk? So actually, my take-home messages are 3 big problems of map quality assessment for the robots in the wild. So the first one is that we don't have a clear definition what a good map is. We don't have well-defined methods to assess the map quality that are applicable in the wild outside of the test beds and outside of benchmark tests. And we don't have widely accepted tools that can be used by the robotic community to perform map quality assessment in the wild. Thank you very much. And I'm looking for questions. I'm waiting for questions. Okay, in case that there are no questions. Okay, okay. Yes.
Yeah, thanks. Thank you. But you leave me kind of depressed, right? It's an image that we have very few tools, and there's a lot of work left to do.
Yes, that's sort of the point.
Yeah, but I think that's correct. But I'm thinking one thing. You said that if you're looking at the utility criterion, one difficulty is that you can't just look at the map and say something about the utility, because it depends on how good your path planner is or something. And my spontaneous reaction was that maybe a way to get out of this deadlock is that you would need to formulate something that is independent of the performance of your module. So you could say somehow, what are there any generic properties of a map to be used for path planning, for example? And then you could do that. I'm thinking, have you thought about a way to decouple that, so you don't, because otherwise there's no objective measurement, right? You will depend on everything else.
Actually, my trail of thought is sort of to actually go to the appearance criterion, to do a bit of research answering this question, like, okay, so what does make localization good? What does make motion planning good? Extract those features of the map that are saying like, okay, the map with following feature is good for motion planning, or the map with following feature is good for localization, and then just focus on this and say like, okay, so those are the features that we are looking in the map, and then basically develop algorithms that will be looking for those features in the maps. So I'm a bit cautious about the decoupling, about this decoupling and using the utility criterion, because I have this concern that maybe it will be not really possible to execute such feat. That maybe it's not really possible to say like, okay, I have this whole stack of modules that are interacting with each other, but I can sort of not look at their impact, and it's enough if I just see the output of the performance. So long story short, I want to go into the appearance criterion However, not in just this naive way of saying like, okay, this map is similar with the ground truth. I want to see what kind of features are desired in a good map.
Mm-hmm. Yeah, okay, thanks.
Thank you very much. Any more questions? Oh, Francesco? I will.
Okay, just building up on what you are saying. When you say I would look at the features that are needed, so this means that features can change according to the task for which the map is used, right?
Yes, very much.
Okay, and it may also change with time. So it is time and task dependent, and
Yes.
okay, yeah. It is not a static set of.
No.
Okay.
That's why I showed like this introspection loop that is constantly assessing what the robot knows about the world and checking what can be used or not.
Okay, thank you.
I see a hand from rising from Luca Carlone. Do you want to get? Let me just.
I have a question. I don't know if you guys can hear me.
You, so you can talk.
Can you guys hear me?
Yes.
All right. So, Thomas, first of all, great talk. A lot of insights. I loved it. I was curious about what do you think about the role of learning, in particular in the reference-free assessment process? Because in my opinion, in the reference-free assessment process, assuming that you build them up, by maximizing the likelihood of the measurements, essentially the only thing that is left for you to use in the assessment process are the priors, right? Priors on the map, priors on what you expect, and possibly there is some role for learning those priors. I was curious if you have thoughts about that.
So I would say two things. That in the case when you are building the map, so first of all, learning I think will be extremely important, although it cannot be used naively. That's the first thing, because what is happening now, for example, in the deep learning community, in wider sense, not only related to robotics, is that let's learn everything and let's throw as much data as possible and do end-to-end learning. And all the successful examples of deep learning shows that no, deep learning is an important tool, but when used wisely. So that's like the first answer on the question. The second part of your question, like where you sort of make this assumption that we are building the map, I would say that this is not always the thing, because during today's talk we have been discussing a lot about maps exchange between different platforms, about inheriting maps of the environment from a previous robot or previous generations of the robots, and so on and so forth. That means that the learning in this context has to be very much diversified. So in the case when we are building the map, we'll have to develop some kind of tools that will allow us to actually to assess how well the map is being built. So exactly, I'm quoting you here, so map certificate, Slum certification. But on the other hand, we still need to look into the problem of how to assess already built and sort of finished, completed map, because this will impose substantially different set of problems. Because in case when we are assessing the map that we are building, we have so much more information that we can use and play with, in contrast to a map that is just being sort of given from some other platform, from like a black box that is hanging in the environment and still requires some refinement with time. So yeah, this is my general reflection on the topic.
Cool. Okay, thanks.
Okay, so thank you very much. And actually now it's your time. So Luca, the floor is yours.